Over the last several videos, I've been building an AI-assisted security assessment framework. It started with relatively simple security maturity model, if you remember. Then I realized that maturity models and scores weren't really capturing the relationship between security controls and actual risks. So I replaced that with Bayesian networks. I then added multiple security experts to just play around with them, connected all of that to LLM, and added business outcome, tested it against the realistic Databricks or Fabric platforms, and most recently moved all of that expert knowledge into Neo4j. And now I have something that technically works, but there is a much more important question. Would anyone actually use this in the real world? And if so, what would they use it for? That's what I want to explore today. But before we answer that, let's quickly establish what I've actually built, like a quick recap. The LLM is responsible for human interaction. It conducts an interview and collects information about the security controls implemented in a given environment. That information then becomes a structured evidence that is used by Python and Bayesian networks that is built on top of knowledge stored in Neo4j. The Bayesian engine itself, it takes that evidence and calculates the likelihood of different security incidents first, and then from those incidents, it grows up and up to potential business impacts. Finally, LLM takes back all of those results from the inference and translates them back into something that is understandable by a human. So essentially, LLM for communication, Neo4j for expert knowledge, and Bayesian network for reasoning. And that is actually an important distinction, because I deliberately not asking LLM, here is my architecture, how secure I am. Because, well, while it will give me a very convincing answer, it won't necessarily know how that answer was reached, and I want to be in control. Now, let's compare this with more traditional security assessment. Obviously, there are many different approaches, but typically the process might involve someone sends you a questionnaire. There are meetings with engineers and architects and whatnot. Then you collect all of those architecture diagrams, policies, and additional documentation as evidence. Then security specialist will review everything and answer those questionnaire questions. And controls are mapped against specific frameworks that you aiming to achieve. Then all of the findings are documented. Eventually you will get back the report, and quite often you get some sort of a score. Like with all of those maturity models, you might get that your IAM maturity is 3 out of 5, or your network security is 4 out of 5. And that information can absolutely be useful, don't get me wrong, but there is a problem. And I've been exploring this throughout this series. Knowing that secret management is 2 out of 5 doesn't automatically tell me what I'm actually worried about, and more importantly, what should I fix first. That's the problem I wanted the probabilistic model to address. So, the first real-world use case that I can see is an architecture security review. Imagine a team building a new data platform, maybe it is Databricks, maybe it's Snowflake, and before production, someone needs to review that architecture, right? Today, that might mean bringing a security architect into several workshops, but with this system, the initial assessment could be partially automated. The LLM interviews the team instead of the security architect. These questions like, do you enforce MFA, do you have privileged accounts, or how do you manage them, and so on. You've seen them from my proof of concept videos. And those answers, that is the important bit, they become structured evidence. Then the Bayesian model will propagate and run that evidence through the security knowledge graph. And instead of only producing you are missing 6 controls, or something along those lines, we might get that the unauthorized access is high likelihood, supply chain compromise is medium likelihood, and regulatory impact from the business is elevated. Now, based on that, the security architect has somewhere to start. And I think that's important. It's not replacing the architect here, I'm just reducing the amount of time those people spend discovering the obvious things. The human can concentrate on challenging assumptions and understanding the context and investigating the areas where the model identified as important. The second use case is probably even more interesting. Security assessments are often just a snapshot in time. We access the environment, we produce a report, and then the environment completely changes. New services can appear, permissions can change, new vendor can get access to the system, and basically 6 months later, that original assessment may completely outdated. But imagine if the assessment were repeatable. In January, we might get a score something like unauthorized access probability is 72%. But the organization introduced PAM, removed the shared account, and tightens the service account permissions. Run the assessment again. Now perhaps you might have something like unauthorized access probability is 41%. The exact numbers is not an important part. The interesting part is that movement, that dynamics. We can ask, did our security investment actually move the model in the direction that we expected? And with those 72% versus 41%, we can clearly see that, there was a positive movement in that direction. That starts turning that security assessment from a document into an ongoing decision supporting process. And the last use case, I might find the most realistic, to be honest. Imagine you're a security consultant and you've performed dozens and hundreds of those assessments. You've developed a lot of knowledge about all of those areas like IAM or networking or secrets and so on. But most of that expertise sits in your head. Maybe some of it exists in documents and checklists that you produced as you worked. But what if we could encode part of that reasoning explicitly? For example, missing MFA will contribute to identity risk. Excessive permissions will contribute to unauthorized access. Weak CI/CD controls contribute to supply chain compromise, and so on. Basically, those incidents can ultimately contribute to revenue, regulatory, or customer impact. What we've seen in my very quick proof of concept type of work. And instead of AI replacing consultants, the system becomes a way of scaling that consultant's reasoning to a much wider degree. The machine handles that repetitive assessment logic, and consultants, they just handle the things machines are bad at, like context, exceptions, business priorities, and human judgment. To me, that is a much more realistic role for AI in security. And there is another reason I think this approach has potential. Once we have a probabilistic model, we can run scenarios. And suppose our current assessment identifies high unauthorized access risk. Management has budget for one initiative only. We could implement PAM, or we could improve network segmentation, or potentially we could improve monitoring. And instead of just saying that all three are recommended, we can change the evidence that we collected and run inference again with PAM implemented, or with network segmentation implemented, or with monitoring in a higher state. So what will happen to incident likelihood if we implement just PAM? What happens to the business impact in that case? And now we are asking which change gives us the biggest risk reduction right now? And that is much closer to the questions manager actually have to answer. Not are we perfectly secure, but given limited money and limited people, where should we invest next? So far, this probability sounds quite positive, right? But there are some major limitations. I highlighted them before, but I wanted to repeat them because they are quite important. First, those probabilities are not predictions of the future. If the engine says customer impact is 65%, That doesn't mean that there is a scientifically 65% chance that customers will be affected. The conditional probability is currently in code expert judgment only. They haven't been calibrated against millions of real security incidents. If you would compare this model to something that actual insurance companies, for example, use, then those numbers for the insurance companies would be much more real because they have millions of use cases and they can base their probabilities on some real models. Whereas with this one, first of all, the number of incidents that we have access to is much smaller. Secondly, the data about those incidents is not that good. And lastly, it was built just by myself so far, so I have a limited amount of energy. So I wouldn't treat them primarily as a consistent way to compare risks and scenarios, not as actual statistics, but it is a first step forward. The second problem is evidence. Right now, the system mostly trusts the interview. If I ask, is MFA enforced? And someone says yes, the model accepts it. But perhaps MFA is enabled for normal employees, but not administrators. Perhaps there are some service accounts outside of the identity provider. Or maybe there is a legacy application with local authentication. The model doesn't know those bits and pieces unless we give it that evidence. So a serious implementation couldn't purely rely on a LLM interview. It would eventually need to validate the evidence, to check cloud APIs, to see the Terraform state, or to run security scanners of your containers, and so on. And as I said, there is also a deeper limitation. I moved that expert knowledge from JSON into Neo4j. That makes the relationships much easier to see and validate, but a graph doesn't magically make those relationships correct. Someone still has to decide if this control influences this risk by that percentage, how strongly it actually influences that. Does this incident influences this business outcome? And what should be the conditional probability be? Those are the expert decisions, and that's why in the beginning those were called experts, and that's why I kept expert nodes in Neo4j still. So the system doesn't remove the human judgment. In some ways it makes human judgment more explicit. And I actually think that's a benefit, because now we can inspect those relationships, change it, version them, and potentially compare models created by different experts. There are a few things I would absolutely not use this system for. I wouldn't say the model says that you are secure, therefore you are secure. I wouldn't use it as a replacement for pen testing, and I wouldn't use it as an automatic compliance certification engine. And I wouldn't remove the security architect from the process for sure. This is just a decision supporting system, not an autonomous security authority. After building this framework, I think the answer to the question, would I actually use it, is yes. But probably not in a way I imagined it originally. At the beginning of this project, the question was, can AI govern data platform security? Now, I think that's actually the wrong question. The more interesting question is, can we capture expert security reasoning in a reusable model and use AI to make that reasoning easier to apply? And I think the answer to that question is much more promising. The LLM doesn't need to be a security expert. It can just collect information and interact with people. It can explain complicated results in a human readable and understandable way. The actual reasoning lives somewhere else, and it is explicit. In this case, security knowledge graph combined with Bayesian inference. So that gives us something we can inspect, challenge, and improve.